Hi, today we are looking at inverse trigonometric functions. So first we're going to look at sine and its inverse of sine -1x, also known as arcsine of x. So here's our original graph of y equals sine x. Now, if we're to take the inverse of this, the inverse will not be a function because we'll have multiple y values used for a given x value. So because of that, what we do is we restrict our domain on this original. So we're going to restrict it between this point and this point. So between negative pi over 2 comma negative 1 and pi over 2 comma 1. Which means as we're solving questions, we're just going to focus on the domain between these two. And that's essentially what your calculator tends to do. So our domain would be from negative pi over 2 to positive pi over 2, and our range of this function would be from negative 1 to positive 1. Now, by restricting this domain, that means our inverse is a function, so we essentially have this here. So this endpoint here is actually at negative 1, comma, negative pi over 2. Well, this point here is at 1 comma pi over 2. So as expected with an inverse, our domain of their inverse is the same as the range of original. So negative 1 to positive 1, and same idea with our range. So it's from negative pi over 2 to pi over 2. Now, if we were to look at the domain of this in terms of, say, a unit circle, seeing our trig functions are often based off our unit circle, it would essentially be these two quadrants. So for example, evaluate sine negative 1 of root 3 pi over 2. So as we just talked about in the previous one, because it's sine negative 1, we're only really looking at this part of our unit circle. And we're looking for where it's positive 3 pi over 2. And we know sine is opposite over hypotenuse. So because it's positive for root 3, that means our vertical component is positive. So therefore, we'd be something like this. So we know that this is root 3, this is 2. And you should recognize that as a special triangle. So we know that this is going to equal pi over 3. That's when we've got sine negative 1 of negative 1/2. So same idea, where if we were to have, say, our unit circle, the domain we're dealing with is over here. Now this is the same as opposite over hypotenuse. So our hypotenuse is always positive. So therefore, we know that that's positive 2, and our opposite would have to be negative. So therefore, it would be this angle here. And we should recognize that as pi over 6, or a reference of pi over 6 giving us angle of negative pi over 6. Next one, we've got sine negative 1 of sine pi over 4. First off, if we have pi over 4, that matches a special triangle. So we know that the triangle that has pi over 4 as a reference angle has two identical angles, two identical sides. So this is 1, 1, square root of 2. So we have sine negative 1 of 1 over root 2 and this will essentially just take us directly back to sine pi over 4, to an angle of pi over 4, because we know sine of pi over 4 gives us that 1 over root 2. Now looking at cosine and its inverse, so cos negative 1 of x, or y equals arc cos of x, we have our graph of cos x, and here's our graph of cos negative 1x, or arc cos of x. Now you'll see that once again we've restricted our domain of this one so that this one is a function. So in restricting that domain, we have restricted it from here to here. So that's from 0, 1 to pi, negative 1. So our domain is going to be from 0 to pi, and our range is going to be from negative 1 to positive 1. Where this one will have the inverse of O, so our domain would be from negative 1 to positive 1. So this point would be 1, pi, and this point would be, sorry, negative 1, pi, and this point would be 1, 0. So our range would be from 0 to pi. Now, in terms of a unit circle, because we're going from 0 to pi, that would be this set. That would be these two quadrants here. So for example, evaluate cos negative 1 of 1/2. Now, like I mentioned, our domain is restricted. So we're looking at this section here. Now, cos we know is our adjacent over a hypotenuse. Now, if we have a negative, that can only go if our adjacent, because our hypotenuse is always positive. So therefore, our angle must be over here. So that would give us an adjacent of -1 and a hypotenuse of 2. Now we know that this angle is pi over 3, but that's just our reference. To get this angle here, we'll just go pi minus pi over 3, and that gives us 2 pi over 3. Next one, we've got cos -1 of cos of 5 pi over 6. So cos 5 pi over 6, if we were to draw that out, cos of 5 pi over 6 would be over here. If that's 5 pi over 6, that gives us pi over 6, which gives us this side being 1, this side being 2, this being -√3. So therefore, cos -1 of cos 5 pi over 6 is cos -1 of -√3 over 2. Now, because our cos has this domain here, when we go to do the cos -1, it's automatically going to be this angle. So therefore, it's equal to 5 pi over 6. Okay, next trig function is tan. So we've got tan -1, or y equals arc tan x. So to restrict this original so that this new one's a function, we're going to restrict it based off of our vertical asymptotes here and here. So we'll say our domain is from -pi over 2 to +pi over 2, while our range goes from -infinity to +infinity, which means that for this one, our domain is from -infinity to +infinity, and our range is from -pi over 2 to pi over 2. In terms of what part of a unit circle we're dealing with, we're going from -pi over 2 to +pi over 2, so we'd be looking at just this part of our unit circle. The next one, we've got tan -1 equals -√3. Now, we could rewrite -√3 as -√3 over 1. We know that we have to be in these two quadrants. So therefore, in order to have a negative, it's going to have to be in this quadrant, because in this quadrant, our opposite and adjacent are both positive. So therefore, if I'm say down here, my opposite is -√3, while my adjacent is 1. We should recognize that as a special triangle. So this would be pi over 3. So going from here this way would be -pi over 3. Okay, so some more identities. Our inverse of cosecant is sine -1 of 1 over x. Our inverse of secant x is cos negative 1 of 1 over x, and our inverse of cotangent x is pi over 2 minus tan inverse of x. Okay, next example, we want to find an algebraic expression for tan of sine negative 1x. So for this, I'm going to use a let statement to help me solve it. So I'm going to say let theta equal sine negative 1x. If we do that, we can therefore say sine theta is equal to x. Now from our looking at sine and our arc sine earlier, we know that we are now just dealing with a domain from negative pi over 2 to positive pi over 2 for sine. Now, if sine theta equals x, and we know that sine of an angle is our opposite over hypotenuse, we can surmise that sine theta equals x is the same as saying equals x over 1. And now we're going to use this to draw out a triangle. So if this is our angle theta, we know this is 1, this is x. We can use basic trig or Pythagoras to get this side here. So we know c squared equals a squared plus b squared. So if we have c squared minus a squared equals b squared, and now if we want to substitute our values in, we have 1 squared minus x squared equals b squared, and then take the square root of both sides, and that gives us 1 minus x squared is equal to b. So we know this side here is 1 minus, or sorry, is equal to the square root of 1 minus x squared. Now we had tan of sine negative 1 of x. Now we said that sine negative 1 of x was theta, so we're looking for what tan of theta is. Now based off of this triangle, tan is our opposite, which is x, over our adjacent, which is the square root of 1 minus x squared. Okay, next example. Find an algebraic expression for cos of 2 tan negative 1 of x. So just like the last one, I'm going to use a let statement to get this started. So we're going to say let theta equal tan negative 1x. And therefore, we know tan of it, or sorry, tan of theta equals x. And using the same logic as we did before, we can say tan theta equals x over 1. Now we're going to draw out a triangle just like with that previous example. Now tan is our opposites, or opposites x, our adjacent is 1, and we have this unknown side. So we'll use Pythagoras again. So c squared equals a squared plus b squared. So we have c squared equals 1 squared plus x squared. So c is equal to square root of 1 plus x squared. So we can fill that in. Now, we go back to what we had here. That was cos of 2 times tan, or sorry, cos of, 2 times tan negative 1 of x. And we said tan negative 1 of x was theta, so that's cos of 2 theta. Now, we can use one of our trig identities because we have cos 2 theta in our trig identities. So this is the same as saying cos squared theta minus sine squared theta. Now cos is our adjacent over our hypotenuse. Now we're squaring that. Minus sine, which is our x, which is our opposite, over our hypotenuse, which is our 1 plus x squared. And once again, we're squaring that. So that gives us 1 over 1 plus x squared minus x squared over 1 plus x squared. We've got the same denominator, so we can combine these. So this is 1 minus x squared over 1 plus x squared. And this would be our answer.